Hi, everyone. Today I'll be giving a talk on how to create preview environments using Terraform Cloud, GitHub Actions, and Vercel. My name is Rita Sokolova, and I'm a product education engineer working on Terraform at HashiCorp. So what are preview environments and why use them? At this point, there's been widespread adoption of CI/CD as a way to allow teams to ship improvements to their products faster. And preview environments are a nice complement to this paradigm in that they allow you to have a realistic preview of the changes that you're considering shipping to production. So this allows you to deploy dynamic environments for every pull request that you have in the configured repository, rather than having to coordinate across preset staging environments. So rather than having something like this, where you have perhaps 3 QA environments that all of your developers have to coordinate across, you have a setup like this, where for every pull request that a developer is working on, a dynamic preview environment is provisioned, allowing them to share a view of whatever changes they're considering or working on. So I'll be showing a workflow that will, as described, create a new environment for every pull request on my configured repository. And this setup uses 3 different services. So I'll be using Terraform Cloud to deploy and manage the resources that I need for every preview environment. I'm using Vercel to deploy the front-end framework for my application. And then I'll configure GitHub Actions to trigger the workflow that will create these preview environments off of every pull request. My configuration is split across 2 repositories. So there's one set of shared resources that is referenced by every other preview environment that I'll deploy. So this collection contains my networking components, such as my VPC and my subnets. It also contains a shared cell-signed TLS certificate that I'll use for all of my preview environments, and the Vercel project that will contain all of the preview deployments. So I'll deploy this configuration once at the beginning and won't need to manage it again. Then I have a collection of per environment resources which live in a different repository. So for every pull request, these resources will be spun up as part of that preview environment. For my configuration, this contains a load balancer with the I should say I'm using AWS as the cloud provider for my demo, but my configuration contains a load balancer with the listener and target group configured, a Vercel deployment specific to that preview environment, an EC2 instance that will house the backend services for my application, and the preview environment will also spin up its own Terraform Cloud workspace. All of these resources will reference the shared resources that I have to deploy just once. So to get this working, I'll first need to create and configure my credentials, then create the workspace of shared resources, enable remote state sharing. So in order to access the resources that are in that shared Terraform Cloud workspace, I need to allow other workspaces in my organization to access that shared workspace's state. I'll then configure GitHub Actions in my application repository. And at the end, I'll create and close a pull request to demonstrate how the workflow works. For the demo, I'm using an application called HashiCups, which allows you to order HashiCorp themed coffee drinks. In terms of the architecture, ignore my red squiggles. In terms of the architecture, I have a React front end, and then I have a payments and product API and a Postgres database. Now, Vercel can support serverless deployments, but for something that has a collection of backend services like this, it's best to use Terraform to manage all of those other components. For my deployment, I'll be deploying these backend services as containers on an EC2 instance, and that'll be managed by Docker Compose. So the one-time configuration, some of this I'd done beforehand, but I'll demonstrate how it looks at the end. So first I had to gather and create my credentials and tokens for the various services I'm using. So this included my AWS credential set, my Terraform Cloud API token. So here you would have the option of using either a personal token or a team token. One of the dangers of using a personal token is that that token has permissions to every organization that your user is a member of. A team token allows it to be scoped to the organization that that team is a part of. So it's preferable to use something like that. And then I also needed to set up my Vercel API token in order to manage the Vercel project and deployments. So to manage the credentials in Terraform Cloud, I'm using variable sets. If you're not familiar, variable sets are one of the newer Terraform Cloud features. It's currently in beta. And what this allows you to do is to define a set of variables that you can then associate with multiple workspaces. So in the past, you would have had to set the same variable over and over again in every single workspace that needed it. This allows you to just set it in one place, manage it in a centralized way. You could use this for something like environment-specific settings for your EC2 instances, but you could also use it for credentials. Now, that's something to be careful with, because if you don't manage the scope carefully, there could be credential leakage. If your organization is not yet ready to adopt something like the Vault plugin for credential management, this is a good stopgap that will let you manage your credentials in a centralized and safe way. So to demonstrate what those look like, once I've created my variable sets, there'll be an organization level resource. And I have two defined now. So the first is my AWS credentials, which contains my access key ID and my secret access key. And these are both sensitive environment variables. And I also have a credential set, or a variable set, for my Vercel API token. And this is also a sensitive environment variable. Now, notice for both of these, I've selected all workspaces as the scope. Because my workspaces will be created dynamically by every pull request, I don't know ahead of time what the name of those workspaces will be. So I have to set a global scope for the credentials to apply to all future workspaces. In addition to that, I deployed the shared resources and created the workspace for the shared resources ahead of time. So let's jump in and review what is in there. So pretty standard Terraform configuration. To start, I'm using the public VPC module to provision my VPC and the subnets. Then I have a shared security group. I expect all deployments of my application to have the same security group requirements. So rather than creating one for every preview environment, I've created one that will be shared by all of them. So this will allow ingress traffic on ports 443 and 8080 and all egress traffic. Then my application also expects an HTTP secure backend. So I'm creating and uploading a self-signed certificate. And finally, there's the shared Vercel project that will house all of the preview deployments for my preview environments. Now, I also have defined a set of outputs, and this will allow my preview environments to access the resources that I've defined here and reference them in their own configuration. So in Terraform Cloud itself, where I've already created these resources, they live in this shared backend workspace. So I have the list of all of my resources as expected. There are quite a few since there are some networking components in there. And I have all of the outputs. So that includes the security group ID that my preview environments will reference, public subnets, my certificate ARN, the project ID, and the VPC ID. Now, importantly for this to work, I also had to enable remote state sharing, which is a general setting on the workspace. So if I scroll down here under remote state sharing, once again, I've selected share with all places in the organization because they'll be dynamically generated. So once I deployed those resources, I also had to configure my application repository. So this is the second repository that contains my application code, along with the configuration for my preview environments and the GitHub Action workflow that I'll use for this. Now, for this to work, I got my Terraform Cloud API token and set it as a repository secret for the GitHub Action to work. The workflow that I'm using will use the Terraform Cloud API in order to manage workspaces for me, and it'll reference this API token to be able to do that. So those are all of the one-time configuration steps that I had to take in order for the rest of the workflow to take flight. So to recap, I created variable sets for my AWS and Vercel credentials. I deployed the shared resources using Terraform Cloud, enabled remote state sharing for that workspace that's managing the shared resources, and I configured my application repository with GitHub Action secrets containing my Terraform Cloud API token. And now to jump into my application repository. So as mentioned before, this contains my HashiCorp's application code, which I won't be reviewing in detail. The preview environment Terraform module. So this defines all of the resources that are needed for every individual preview environment that will be deployed. And it also has the code for my GitHub Action workflow. So I'll be reviewing these in a little bit more detail, but I'm just going to kick off one of the workflows and kind of go through it while we wait for that to finish. So working now in my application repository, I'm going to make a small change to the front end. Just to add a bit of text. So let's see. First, we'll just render HashiCorps on the page. I'm going to check out a new branch and commit my changes. Up. And then I'll have to open the PR. So I'm using a forked repository for this, so I have to make sure that I'm using the correct base repo and just create the pull request. After this, I can expect the GitHub Action workflow to kick off. There we go. And this will take a few minutes to run. So in the meanwhile, I'll review the module configuration. So to start, I have this preview environment module defined here. As mentioned before, this uses Terraform Remote State in order to access the outputs from that shared resource workspace. And it references that workspace by name here. Further below, I have the definition for my EC2 instance, which is going to host those Docker containers with my backend services. Now notice that this is referencing the outputs from that shared resource workspace for the subnet IDs and for the security groups for this configuration. I also have my load balancer configuration along with the listener and the target group that attaches my EC2 instance to the load balancer. And once again, this is referencing some of the outputs in that shared resources collection. So I'm using that TLS cert for the listener and the VPC for the target group configuration. Now, the other thing you'll notice is that I'm actually using the name of the workspace to name all of these resources. Since I'm spinning up resources dynamically, this makes it easier for me to identify which workspace each resource is associated with. I also have the Vercel deployment specific to this branch. my outputs, which include the load balancer endpoint and the preview URL for my Vercel deployment, and a few environment variables. This is prod one will come into play. My GitHub action workflow will toggle this depending on whether I'm opening, closing, or merging a pull request. And that'll determine whether I'm creating a preview environment or if I'm pushing my changes to the production project. Let's just quickly check on where my GitHub workflow is right now. Still running. Okay, so we can keep going here. So at the top level, I have an instantiation of that module, and it's pretty simple. It's just referencing that is prod environment variable. It's surfacing two of the outputs from my module. So I'll review this in more detail in just a bit, but my GitHub action workflow actually grabs these two outputs and posts them as a comment on the pull request. So that'll give any reviewers easy access to the preview environment to check out. And then the final crucial component of this configuration is actually this workspaces block. So this, as is right now, is a placeholder. My GitHub action workflow will replace this with a workspace that interpolates in the name of my branch. And when the GitHub action initializes the configuration, Terraform will immediately create a corresponding Terraform Cloud workspace for my resources. Now, just going to check on this again. Still going. So let's take a look at the GitHub action workflow. So this consists of, I believe, 8 steps, but not all of them will run every time. It'll depend on whether I'm opening, closing, merging the PR. The configuration relies on 2 environment variables, one of which is the workspace name that interpolates in the name of the current branch, and my Terraform Cloud organization name. So to start, it checks out the current commit on the branch, configures Terraform within the GitHub action workflow environment, and it references that Terraform Cloud API token that I set as a secret to allow it to authenticate with my Terraform Cloud organization. Then I have the sed command that replaces that workspace placeholder with the custom workspace name for this configuration, and it initializes it, which creates that workspace. Then if I'm opening a new pull request, it'll apply the configuration specified by that preview environment module to spin up all of my resources. It'll grab the outputs from my configuration, and then it'll create a comment on my pull request with their values. Then finally, the cleanup. So if I'm merging or closing a pull request, it'll destroy the preview environment. So first, it will run a Terraform destroy within that workspace, and then it'll use the Terraform Cloud API to destroy the workspace itself. So cleans everything up for me. And in the case of a merge into my main branch, it'll actually change the name of my workspace to my designated production workspace and apply my changes there to ship them to production. So yes, great. And now the workflow is completed. So if I go to my pull request, I have the comment with my load balancer and a preview URL. Since I'm using a self-signed cert, I have to accept it in order for this to work. Cool. And then I can check out my change. And as expected, this is the bit of text that I added in my pull request, and everything looks in order. Now on the Terraform Cloud side, the workflow created a new workspace, and it's this one. So this contains the name of the branch that I created. And in here, it has the list of all of the resources that are managed as part of my preview environment. And it contains the same we saw posted in the PR comment. The other thing of note here is the variable configuration. So since I set global scope on my credentials, it applied my AWS access key ID, my secret access key, and my Vercel API token here. So I'm not going to merge this change. And to show you how this works, I'm going to just close the pull request, and we'll see the closed pull request workflow kick off. So in just a bit, we should see a new run triggered here that will destroy all the resources in this preview environment. We'll give this a second. Let's see. Cool. So it's in action. And it triggered the destroy run. So all these resources will be gone in a moment, and we won't even be able to access the workspace. So while that runs, let me review the different steps that are part of the different workflows depending on the GitHub action I take. So in the case of opening a PR, it's going to build a preview environment. So to do that, it'll check out the configuration for the pull request branch. It'll initialize Terraform within the GitHub action environment. Then it'll initialize the configuration, which will create that unique workspace, build and deploy the module with all the resources, and then grab the Terraform output and drop it as a comment on the PR. If I'm closing it, it'll check out my configuration, configure Terraform within the GitHub action environment, and initialize it, and then destroy the preview environment and destroy the workspace. If I merge a pull request, it'll check out the branch, set up Terraform, and then change that workspace name to be the production workspace and deploy my changes to prod. Now, merging a PR also closes it. So when I close the pull request, when I merge the pull request, it'll also go through these steps to clean up the resources that are part of my preview environment. So let's see how this looks as it's wrapping up. Okay, and I can't even access the workspace. So as expected, this is all cleaned up. This should no longer, well, that might take a sec to disappear. But the workflow completed and my pull request is closed. So in the case of a merge to production, it would actually push the changes here and update the Vercel deployment that my prod configuration uses. So now you've seen it in action. You see the benefits of preview environments. They're dynamically set up. Don't have to coordinate with anyone else in order for this to work. We have a tutorial corresponding to this configuration and workflow. So if you want to try it yourself, visit learn.hashicorp.com to give it a shot. Thanks.